So I began my career as a civil engineer, so not really as exciting as Peter and his whiskey making. I married a civil engineer. We have 6 daughters. None of them became civil engineers. We made it look that exciting. But I think this is a very exciting time for all AEC professionals. So I'm going to talk about new ways of integrating GIS technologies with BIM processes, because this is one of the biggest things I think that's happening in the business today. So it's really enabling AEC professionals to remove silos between GIS teams and engineering and design teams. And that's whether or not they work with buildings or they work outside the building in the civil engineering field like I do. So I've been with Autodesk for about 11 years. And for people that are or are not familiar with Autodesk, Autodesk probably touches or is seen in a lot of places around you that you may not even be, aware of. So Autodesk and our customers are responsible for designing and constructing a lot of buildings, bridges, components for cars, but also for blockbuster movies and video games. So if you work in the industry, the AEC industry, you know that it's massive and growing, and you can see this in the growth all around us. So new developments, infrastructure projects, you see tower cranes and construction crews. So we did a research project with a company called Statista, who helped us kind of put some numbers to this growth. And based on the research that they did, they determined that about 13,000 buildings per day are going to need to be built every year between now and 2050. In addition to the buildings, road networks, rail networks are going to circle the earth 30 times every year, again, between now and 2050. So that is a lot of infrastructure that's going to be going up around us. And again, that's every year between now and 2050. So we know more is inevitable. The demand for more is being driven by demographic changes that are already underway. So one way that we think that we'll be able to help the industry create all of this new infrastructure is with BIM, or Building Information Modeling. And I think a lot of people think BIM is just about buildings and designing buildings, but BIM is really defined as a collaborative process where you create and exchange information throughout the course of a project's life cycle. And really, it's about connecting information, intelligent, structured information, to three-dimensional models, and then using that information to help you design, construct, and ultimately passing that information on so that it can be used in asset management. So the need for all this new buildings and infrastructure is just one of the things that's driving integrated BIM and GIS workflows, and the need for it, and the actual requirements that are coming out of it. So the AEC industry is currently in a state of advancement and change. So technology is influencing every part of the way projects are designed, built, and operated. BIM standards and processes are increasingly becoming a requirement to working on projects with growing complexity. So the bottom line is the need for centralized data, or a way for information to be shared centrally. And we like to think of this as the I in both BIM and GIS. And that's kind of where the convergence is coming together. So we see things coming together as engineering teams begin to ask for up-to-date access to information about the built and natural environment. So they want to be able to analyze, plan, and design change in the world around them. So the understanding of an asset, whether it's a building, a roadway, a new rail station, without the larger contextual environment, that's not the way people are going to work. They need all of that information so that they can make better decisions, make more informed decisions, smarter decisions, and improve stakeholder engagement. So ESRI and Autodesk announced their strategic alliance about 2 years ago, which excited many of the people who are our customers. I think it excited more Autodesk customers than it did ESRI customers. And that's because at the ESRI conference, people asked us, what do you guys do? Nobody at the Autodesk conference asked ESRI what they did. But even before our alliance, our customers were already bringing together GIS into their BIM workflows. This is an example that you're seeing up here of a joint venture between two of our Nordic customers where they were looking to design a new high-speed rail line. And it was through a very complex area where they needed to take into account a lot of environmental impacts and also cultural impacts. So to generate the design proposals, the GIS data and analysis results were brought together along with survey data and imagery into a design platform so that they could identify areas of significant environmental and cultural impact. And those were the things that they wanted to make sure that they avoided. So they used a design environment that made use of data-rich, contextual models that teams were able to review different proposals with various stakeholders, all within one model. And so this platform is called Autodesk InfraWorks. So it resulted in an accelerated approval process. So the high points in terms of ROI for this team were their ability to effectively communicate design intent and issues with over 120 stakeholders so that they could drive design approvals by utilizing the extensive overlays of critical constraints that all came from GIS. They also used InfraWorks as kind of a common data environment, so for the entire project team to have a rigorous review cycle of every 14 days. And lastly, the project was able to recognize about a 20% time savings by implementing this process in the planning and approval phase of the project. Now, these types of wins using BIM processes are kind of changing the way people think about BIM. So now many people are thinking about BIM as kind of building an information model so that they can do better design, have more information to take to construction, and ultimately pass the right information to asset management. And this makes sense because in places like the UK, where BIM mandates are in place, standards revolve around creating and managing a model containing digital information about the built asset. Now, to build that information model, different types of data need to come together. So this would include things like reality capture information, other BIM models potentially, IoT, but most importantly, GIS. So even though the team at Swaco and Ramble, the example I showed you before, even though they were successfully able to finish the project with a high degree of collaboration, they had challenges with their GIS and BIM integrated workflow. And that's because they were following a very disconnected process whereby they were asking their GIS teams for information, they were passing them information in files that were very difficult for the teams to manage. So what we have done over the course of the last couple of years is focus some product innovations on really connecting into GIS from a design environment. So in this project example, we see the enhanced workflows brought about by what we call the Autodesk connector for ArcGIS. So it's a feature found in the Autodesk design software, including InfraWorks, which I showed earlier, and what you're seeing here as well. So it's an immersive design environment where teams can create what could be in the context of what is, including this bridge that's currently being designed. So one of the things that design teams want to do, again, is bring that GIS information into their design platform so that they can make decisions about where to place significant pieces of the design. So in this case, we're looking at reaching into ArcGIS Online, grabbing the different underground utility information, and then bringing that into our InfraWorks model. So underground utility information is extremely important when you're locating piers on bridges. And so by looking at this, they determined that there was some missing design or missing underground utilities. So they sent that information out to the teams who were using ArcGIS Collector. So using Collector, they then were able to field verify the different locations of the underground utilities and also to identify locations where they were missing data. So by updating all of that information in the field, they can immediately connect with the design team, who then just simply refreshes because they're connected to the data. They did not import any information. They simply connected. So they update, resync, and now they can see that they're going to have a conflict with the placement of that pier. So they can simply then move that using the design tools in InfraWorks. So this is just an example of what some of our customers are now doing with this new and improved way of integrating GIS technologies with BIM workflows. So since the initial release of the connector for ArcGIS, which happened a year ago because we announced it at the ESRI UC in San Diego in 2018, we've had a lot of positive customer feedback. One of our customers, a gentleman that spoke with me this year at the ESRI UC at the Engineering Summit, Chuck Pietra, who works for C&S Company, has described it as a dream because it has really helped him to accelerate the timelines on some of the projects that he's working on. And so he shared some of his project examples with me that I'm going to share with you. So the first example was on an airport project where a noise study needed to be completed as part of the design. And they created a model of the existing conditions in InfraWorks, including adding things like the terminal building, which was designed in Revit, as well as any underground utility information that they had from the design team that came from our other design software. So this all helped them communicate with stakeholders. But what they wanted to be able to do then was to bring in the information on properties, the parcel information that had all of the owner information, and they needed that for the study analysis. So that's where they used, in a very simple way, plugging into their ArcGIS online data source to get that information to add it to their model. So it's a simple example that for them had impactful return on investment, which was cost and time savings. So the next example involved a large-scale remediation project, and it says large Superfund site, and in the US, a Superfund site is a site where the federal government is providing some money for cleanup to happen on large sites. So over years, there might have been a lot of environmental damage done to a site, and so it's a cleanup project essentially. And one of the things that Chuck mentioned to me about this project was they had a lot of data, a lot of GIS data, but it was in so many different places, in so many different formats. So people had information from ArcInfo, ArcCAD, ArcMap, and what they wanted to do was to bring it all together in one central location. So they created a repository using ArcGIS online that they were then able to share with the multiple stakeholders who would be working on these design projects over the course of about 20 years. So they could not afford to have any mistakes where people were just passing files back and forth. So for them, it created a very easy way for them to share the information that design teams would need. And again, we're looking at the course of 20 years. So these are just a couple of things that Chuck and his team at C&S have been using the connector for ArcGIS for. So the last project example I want to show you is an iconic one. So I was lucky enough to be part of a project where we worked with the city of Paris to build a contextual model around the Eiffel Tower as part of a design competition that they were holding. So they had 4 design teams that were finalists who were going to propose a new way of the Eiffel Tower, the area around the Eiffel Tower, reimagining the site there. So they're preparing for the Olympics in 2024. But in addition to just having a beautiful site that could function well for the public, what they also wanted to ensure was that no green space, or the amount of green space that they currently had, was the same or more after the designs were complete. They also had a very robust GIS data source of all of the different trees, so number of trees and the types of trees. And so they wanted to make sure that none of those were disturbed either. So the design teams used, or had the opportunity to use InfraWorks to make sure that all of the goals of the city were met in their final design. This is actually the winning design. And one of the things that you'll notice is the bridge that crosses from the main area over to the Eiffel Tower actually all became a green space. So again, they were trying to fulfill these extra goals that the city of Paris had. So just being able to use the data for design and engineering is valuable, but even more important is the collaboration and connection between the teams, which is a two-way street. So over the course of the last year, in addition to just giving engineering teams access to GIS data, what we also wanted to do is provide a way for the workflow to be two-sided. So if design teams were completing things like changes, if they took information from a GIS and then moved some of the assets that they brought in from that GIS, they could save it back, saving a lot of time on the GIS side where people are having to manually update those data sets. So the latest release of our design software includes the ability for people to save that information back. Next step for us, of course, is to do more of a publish workflow where engineering teams would be able to publish feature services back to a GIS. Of course, only with the permission of the GIS team. So this is the kind of thing that's creating excitement in the industry, and I thank you again for inviting me to come and present today.